So welcome to Reigate College Year 2 Statistics. This is the second video on the inverse normal distribution, and this time we're going to look at finding an unknown mean or an unknown standard deviation, or both unknown. So let's have a look at the first question that we're going to go through to demonstrate this. So we're told that we've got a random variable x, which is normally distributed. We don't know its mean, but we know its standard deviation is 2. And we're also told that the probability that x is less than 25 is 0.7. What we want to do is we want to find the value of the mean. So what we're going to do is we're just going to do a quick sketch of this distribution. We know that all normal distributions follow this bell curve. We know that the mean is in the middle. We also know that 25 is somewhere here, 25, and that this area here is 0.7. It can be very helpful to sketch this out each time. So we're going to say the probability that x is less than 25, 25, not 2.5, is equal to 0.7. We want to find the probability that the standard normal distribution is less than a certain value, is 0.7. We're going to use the inverse normal for that. And then we're going to use z equals x minus mu over sigma, and we're going to rearrange to find mu. So let's go and find the value that we need for z. So remember that z, the standardized normal distribution, is the distribution which has the standard deviation of 1 and a mean of 0. So we're going to put in area of 0.7, and we're going to find the value that gives us that probability of 0.7. I've already put those into the calculator here. So if we press equals, we get this value here is going to be 0.5244. Okay. So we could put here, let's do this in red, z value equals 0.5244. So now we can put all the values that we know into this equation. We can say 0.5244 is equal to the value of x is 25 minus the mean we don't know yet. Standard deviation we know is 2. So then mu is equal to, we need to multiply by 2, and then we need to take it away from 25, don't we? So 25 minus 2 times 0.5244, and that comes out to 23.9512. That's probably greater accuracy than we want to give it to, so let's make it 23.95 to 4 significant figures, or 24.0 to 3 significant figures. So that's question 1. Question 2 is going to work in a very similar way, but this time we don't know sigma. So again, let's sketch a diagram. So this time we've got mean 100, unknown standard deviation, and we've got this probability. So let's sketch that out. Here's our sketch. Here's our mean in the middle, which was 100. And we know that the probability that x is greater than 125. So greater than 125 is 0.1. And that means this area here, of course, is 0.9. So we can say the probability that x, we've got greater than 125 is 0.1, x is less than 125 is 0.9, and again we want to find the value of z that is going to give us that probability of 0.9, so we're going to use the inverse, the standardized inverse normal distribution. So we're going to say probability that z is less than a figure equals 0.9. Let's find what that is. So we're going to go to our calculator again. Here it is. Let's get rid of the previous one. We want area 0.9 now, 0.9, and we're going to press equals, and we get 1.28155. 28155 or 6. Let's put in 55. That's what I've used in my original working. Push this up a bit higher so that you can see it. So again, we're going to use z equals x minus mu divided by sigma. This time it's sigma that we don't know. So our z value is 1.2828155 is equal to our value of x is 125 minus our mean, which is 100, over sigma. So sigma is equal to, this is 25, divided by 1.28155, and that is equal to 19.51 to 4 significant figures, or 19.5 to 3 significant figures. Okay, so let's take that away and have a look at question 5 now. So we've now got a question where we've got unknown mean and unknown standard deviation. Oops, let's put it where you can see it. That's a bit better. So unknown mean, unknown standard deviation. We're given two probabilities this time, and we need to find the value of mu and the value of sigma, giving our answers to 3 significant figures. So for this one, again, let's sketch out our distribution. So question 5. Sketch out our distribution. Here it is. Something like that. Here's our mean in here, and we also don't know sigma, but what we do know is the probability that x is less than 10 is 0.2, so 10 is going to be somewhere over here. 10, that's 0.2, and the probability that x is greater than 20 is 0.1. So there we are there, that's 20, that's 0.1. So we need to find two z values. So let's say for x equals 10, we're going to look up a probability of 0.2 or an area of 0.2. Let's go in here, 0.2 equals, and we get a z value, z equals minus 0.84162. X equals 20. We're now going to look up an area of not 0.1, it's always less than, so 0.9. We actually already looked at that up in the last question, didn't we? Let's put it in again here, 0.9 equals, so that's 1.28155, so it equals 1.28155. And now we're going to use z equals x minus mu over sigma twice. So use z equals x minus mu over sigma twice. So for the first one, we've got, let's see, our z was minus 0.84162 is equal to 10 minus mu over sigma. So that means 10 minus mu is equal to minus 0.84162 sigma. For the second one, we've got 1.28155 is equal to 20 minus mu over sigma. So 20 minus mu is equal to 1.28155 times sigma. Now, if you've got them in a form for your calculator, you can just put these simultaneous equations in on the calculator, but we can solve them by hand as well, so let's just do that now. We're going to say we're going to do 2 minus 1, so that's going to be 20 minus mu minus 10 minus mu, so the minus mu's are going to cancel out. So if we write down 2 minus 1, we're going to get 20 minus 10 is 10 is equal to, we've got this minus this, so we've got 1.28155 plus 0.84162 all times sigma. So sigma is equal to 10 over 1.28155 plus 0.84162, and that comes out to 4.71. 2, 3 significant figures. And then we can work out mu, so we can say that mu is equal to 10, if we rearrange this, 10 plus 0.84162 sigma, 10 plus 0.84162 sigma, and we put in our 4.71, that comes to 13.96, which is 14.023 significant figures. Oops, put that way you can't see it, that's no good. So there we go. Now the last part of this question, which I haven't actually got here, says find the interquartile range giving your answers to 3 significant figures. So the way you're going to do that, let's just do it now, is we're going to say let's use the distribution that we've got now. Let's write that out, x squiggle n, and we've got a mean of 14.0. We've got a standard deviation of 4.71. So lower quartile, we've got, we want to find the probability 0.25, or area equals 0.25. So x equals, well, let's go and use our calculator now. So we're going to say 0.25. We're going to put in the standard deviation of 4.71, and we're going to put in the mean of 14.0. There we go. And we're going to say equals, so we get a value for x of 10.823, And then if we use an area of 0.75, it's the same distance above the mean as the 10.823 is below the mean, so you can do it that way as well. We get 17.177 equals 17.177. Put this way you can see it. So that's area equals 0.75. That's the upper quartile. So the IQR is 17.177 minus 10.823, and that is, I've got another calculator here, so let's put it in on that. 17.177 minus 10.823 is 6.354. So that's the way we're going to calculate the interquartile range. Okay, that's it for the inverse normal distribution function. Thank you for listening.